Hello students, good evening and welcome to this session on polynomials. This is going to be the third part of the three-part series. Alright, so who do we have here with us? Okay, so we have Satish, we have Srija, there's Arslan here with us. We've got Prachi. Hello, good evening to all of you. We have Rafiq Ahmed and Prachi again. Yes, alright, so Arushi is here as well. Hi Arushi. Good evening to all of you. Now, as you know, we've covered the first two parts of the polynomials earlier. Shreya as well. Hi. How are you? I'm doing great. Mona Lisa, Sony as well. Thank you for letting me know that I'm perfectly audible and visible and there are no technical difficulties here. Okay, so as I said, this is going to be the last part of the polynomial series. We've already covered the first two and I'm sure you've understood all of that. Today's session is going to be a fairly simple one. We also have Wasi Khamar with us saying hi along with Tatlin Kaur. Awesome. So I hope you guys are all doing good. Come on, now that I'm perfectly audible and visible, let's begin the session for today. We have Venkatramana joining us as well. Arslan says this may be harder because he's in 7th grade. Now, it's not going to be that difficult as long as you can focus. Okay, come on, let's begin now. I'm going to start the session by first talking about, the BYJU'S classes to teacher advantage. Okay, because finding a home tuition now has become a lot easier with these introductory packages. As you can find, it is as low as 199 rupees. Again, the link to all of this could be found in the descriptions box. Do make sure that you try it out because the advantages are pretty amazing. You have in-depth class assignments and assessments. You have live classes, 1 month premium access to the BYJU'S app. And as I was talking in yesterday's class, you have the live class. Before the live class, you've got to do a little bit of preparation. Like today, we were talking about polynomials. So ideally, what should have happened is, you should have downloaded the BYJU'S app, watched a few videos on algebraic identities that we are covering today, so that, you come a little prepared to the class and you have an idea as to what to expect. Okay, you know what kind of questions you should be asking. You know what concepts are tricky that you should be focusing upon. All right, so those visual content, those animations which are there on the BYJU'S app go a long way in helping you understand it, helping you visualize it. So do make sure you utilize this. And then, you of course know about the two teacher advantage, right? One teacher would be explaining you the concepts and then you have another teacher to take care of all of your doubts, right? And next thing that I'd like to talk about, again, you could find the link to this in the descriptions box. I'm sure you're going to try it and I'm sure you're going to love it. Okay, next. The Telegram channel again. Yeah, this is again going to be fairly important because all the session notes with the teacher's handwriting would be shared only on the Telegram channel. Apart from that, we have some other fun activities for you in the form of quizzes, homework question, all the session updates and the revision question. Again, the link to this could be also found in the descriptions box. Make sure you try that out. Awesome. So let's begin the studies. Now, I'm going to show you a little bit of a visual idea today because just giving you the formulas for the algebraic identities, would have worked as well, but I want you to expand your thinking because this is what I am talking about, the kind of content that exists on our app. So let's talk about this identity first. X plus y whole square. You guys must be familiar with the expansion. X plus y whole square is written as x square plus 2xy plus y square. One proof for that, you could use the distributive property, yes, like x plus y. When you multiply it with x plus y, you know how to open up the brackets, right? First, you multiply this x with x, you get x square. This x gets multiplied with y, so there you go, you have xy. Y gets multiplied with x, you have another xy. Y gets multiplied with y, you have y square. Simplify this and it boils down to x square plus 2xy plus y square. Yes, but I want you to, have a visual understanding of this. All right, let's see how that is to be done. First thing that I'm going to do here is, I hope you can see these animations being played out to my left. First, I have a side of length x. And now I'm going to take a side of length y. I'm going to join them together. Okay, so now this complete length is going to become x plus y, which has been highlighted here for you. All right, I'm going to bring on, 4 such sides now. And the area of this, okay, since all these sides are, this is x, this is y, this is x, this is y, this is x, this is y, all the sides here, the side is equal to x plus y, right? And this is in the form of a square. So the area, of course, is going to be what? Side square, which is x plus y whole square. So now have a look at how you can, convert this algebraic identity into a geometric problem. Okay, so as you can see here, this is x, this is y. Let's break down the area. So you're familiar with these sides now. Yeah, this is xy, this is xy. So the area of this is going to be x square. Yeah, because the sides are x and x. So we get our first part. The area of this is going to be xy. Yes. The area of this is going to be y square. And then the area of this rectangle here is going to be xy. So you see how you could visualize the algebraic identity of x plus y whole square by connecting them to geometrical shapes. Okay, so we have been concerned with the area of the square and area of the rectangle, and this is how it all played out. Okay, because this was x, this was y, this was x, this was y, x, y, x, y. So this area here is going to be x square, because that's a square. This is in the form of a rectangle, so this area is going to be xy. This is in the form of a square with side being y, and this is a rectangle. So add up all the area, and that is going to be equal to x plus y whole square. All right. So I'm sure you guys have understood how you can visualize x plus y whole square. All right. Come on, let's move on now and check out the second identity. The second identity is going to be x minus y whole square, which, as you all know, is x square minus 2xy plus y square. You can also, prove this using the distributive property, because x minus y whole square is nothing but what? X minus y multiplied with x minus y. Use the distributive property, open this up. So x multiplied with x, x square. X multiplied with minus y, minus xy. Minus y multiplied with plus x, minus xy. And minus y multiplied with minus y is going to be plus y square. Simplify this and you are going to get x square minus 2xy plus y square. But now, hang on and check out the visual representation of it. Okay, I'm going to explain you that now. So look, first thing that I've done is I have a side of length x. Okay, now what I'm going to do here is I'm going to cut some part of it. I'm going to call it y. So this purple line that you see here, I can call it x minus y. All right, and this is going to, I hope you've understood what we've done here. First, I've taken a side of length x here. The complete length is x. Now if I call this part as y, then this remaining part is going to be called x minus y, right? I hope now it is understood from the drawing that I did at the top. Okay, so this complete length is x. From that complete length of x, I call some part y, then the remaining part is going to be called x minus y. Yes, come on now, let's build upon this like we did in the earlier question. Okay, now let's try to visualize again the same thing. Yes, so this is x minus y, and then this is going to be the area that we will check out. Okay, so this is x square, and then this is going to be x. Now this is going to be a little important here. You need to understand that. So first thing what I've done is, how do you get this minus xy? It's the area of this complete thing, rectangle, which is a length multiplied with width, and then we are also looking at the area of this complete rectangle. So you see this part here, we are subtracting it 2 times. So that's the reason why what we do here is we add that part back. All right, and this is how you're going to get, Chandan says, okay, I'm going to repeat that again. Look, this may be a little tricky. I understood that. That's the reason why I said, just focus on this. Okay, cool. Let's try to check out x minus y. First thing that you need to understand here is, look, let's take a line here. Okay, this complete black line that I've just drawn, let's suppose is x. You can take it 10, 7, 8, 5, whatever. I'm going to say that, let's just take a different color to illustrate that. Out of this x, let's just say the distance between these 2 red dots that I have is y. All right, so from 10, if you remove 3, the leftover part is going to be what? 10 minus 3, right? Same thing. From x, if you cut y, the remaining part here is going to be x minus y. Okay, Look, x minus y is this, and y is this distance between the two red dots. I'm sure Chandan is focusing on this now. Okay, so this is how this becomes x minus y. Yeah, and now let's try to derive the formula for x minus y whole square visually. Okay, so look, x minus y whole square, first thing that you have is the area of this, that's going to be x square, and as I said, you're taking the area of these two red rectangles 2 times, you're subtracting it 2 times, but then as you can see, this part here gets subtracted 2 times, so that's the reason why you have to add 1 back. All right, and that's the reason why we add the y square back, and this is how after simplification we are going to get x square minus 2xy plus y square. So 2 identities so far. The first one is what? X plus y whole square, which is x square plus 2xy plus y square. The second one is x minus y whole square, which is x square minus 2xy plus y square. Now I'm going to move on with the other identities a bit faster. Now the third identity is going to be x square minus y square, which you guys as know is x minus y multiplied with x plus y. And for that, let's just take a big square of area x. All right. Now what we're going to do here is, from this, I am going to cut out a small square. All right. Let's just say this is y. So automatically, this part will become x minus y, and this part will become x minus y, this part here, from here to here, right? And now if you want to find out x square minus y square, what you're doing is, from the bigger square, from this complete purple sided square, you are cutting this part out. Okay, you are cutting this part out. So the area of this remaining part, which I'm sure you guys can easily find out, is going to be this. Okay, because this side is x minus y. I'm sure you know how to figure out the area of these kind of shapes, right? So you first have to figure out the area of this, and then you have to add to that the area of this, simplify this, and this is going to be in the form of x plus y multiplied with x minus y. All right, so you see, we have visualized 3 identities. We didn't just want to give you the formulas, we wanted to show you how algebra could be visualized as well, right? So we've visualized 3 identities so far, and now this is the 4th identity. Again, this is going to be fairly simple from here on. Yes, so look, this is the first, 4th, yep, x plus a, x plus b multiplied, the same idea that applies with x plus y whole square. Yes, and then this is going to be this x plus a multiplied with x plus b. This is going to be the 4th one here. Okay, and you can pretty much use the distributive property as well, like x plus a, when you multiply it with x plus b, you know how to use the distributive property, right? X multiplied with x, x square, a multiplied with x, ax, x multiplied with b, bx, and then a multiplied with b, ab. Okay, so come on, now let's jump straight away into the questions. Now you've got to figure out the product of x plus 4 using standard algebraic identities. How are you going to do this? How are we going to solve this question? How are we going to figure out the product? What identity are we going to use here? Yes, a plus b whole square, which is, x plus y whole square. So if you compare it with that identity, look, x plus 4 multiplied with x plus 4 is nothing but x plus 4 whole square. Right? Now compare it with x plus y whole square formula. This is nothing but x plus 4 whole square. So as you can see, in the place of x, you've got x. But in the place of y here, you've got 4. Right? So let's do that substitution now. Pretty simple. So x square plus 2 multiplied with x multiplied with 4 plus 4 square. Look, it's pretty simple. In the place of x, you have x. In the place of y here, you have 4. So that's the simple substitution that you guys have to do. That's all. All right. Now this is going to boil down to what? X square plus 2 times 4 is 8. 8 multiplied with x is x. 4 square is going to be 16. That's it. Prachi has given us the correct answer. X square plus 8x plus 16, along with Rafiq as well. Okay, so this is all we are going to be doing in this session today, using identities and simplifying them. Even if you don't use the identities, you should still be able to do it. Okay, like how you're going to do this without the identity? You're going to multiply. Distributive always works. Look, x multiplied with x, x square. 4 multiplied with x, 4x. X multiplied with 4, 4x. 4 multiplied with 4, 16. You will still end up getting the same answer. Do not get into a habit where you are memorizing formulas. In math, actually nothing should be memorized apart from a few fundamentals, things like cubes and squares. Other than that, all of it would be derivable on its own. Because even if you don't remember the formula, it's absolutely fine. In fact, I would encourage you not to. Always derivable by using the distributive property. Okay, come on, let's move on and check out another question now. All right, this one should be good. So this time what we got to do here is factorize a to the power 4 minus 1 using standard algebraic identities. Now the moment you check this out, something should click, and that is, what identity can I use here? And that is this simple identity, x square minus y square. Now if you're asking me how you're going to use this, we've got to do a little bit of algebraic manipulation here. Okay, how? Look, a to the power 4, I'm sure you agree that I can write it like a square whole square. If you have a problem with this, let me know, because this is going to be important. What formula am I using here? A to the power m whole to the power n is going to be a to the power mn. Can I write it this way? A to the power 4, a to the power 4, can I write it like a to the power 2 raised to the power 2? Bhakti says yes. Shivani also says hi. All right, cool. So we can write it this way, right? A power 4 can be written as a square whole square. That is what I'm going to do now. In the place of a to the power 4, I am going to write it like a square whole square. And 1 also can be written like 1 square, right? Because 1 square is nothing but 1. So 1 square also I am going to write it like 1. Sorry, 1 I'm going to write it like 1 square. Yes? Yes, Nitin, of course. Cool. Now, compare this with the formula for x square minus y square. What do you get? When you're comparing it with the formula for x square minus y square, you see that in the place of x, you have a square, and in the place of y, you have 1. Right? When you compare these two results, you would see that in the place of x, you have a square, in the place of y, you have 1. Plug that in. So this is going to be what? A plus b, sorry, x plus y, which is a square plus 1 multiplied with a square minus 1. Right? Very good. A square plus 1. No, Rafiq, the power will not be 4, the power will be 2. Because if that is the case, it would turn up into what? A to the power 8 minus 1. Alright? So the right answer would be like given by Prachi there, a square plus 1 multiplied with a square minus 1. Venkatramana has gone a step further by saying that this can also be further simplified. Yes, I agree with you. A square minus 1 can be again further written as, okay, the final answer is going to be this, a square plus 1, and then a square minus 1 can be written like what? A plus 1 multiplied with a minus 1. Yes or no? A square minus 1, this part here, look, a square minus 1, I can write it like a square minus 1 square, right? Now again, if you compare it with x square minus y square, this can be written as a plus 1 multiplied with a minus 1. Very good. So you guys have understood this. I'm pretty happy for that. Because what we are learning today, guys, is going to, form the foundation. It is going to help you in coordinate geometry later on, but some of it is going to be used in trigonometry, because this is absolute basic. Okay, so you guys should make sure that you master these basic algebraic identities. Awesome, cool. Let's move on now. All right, so this is going to be the fourth identity that we cover. The first one was a plus b whole square, then a minus b whole square, then a square minus b square, then we covered a plus x multiplied with b plus x, okay? Now this is going to be the fifth identity, fairly simple again. You can go ahead and visualize this, okay? This is tricky simple, yeah, cool, come on, come on. Now let's go ahead and check this out. So the purple line, the length is x, then I take another line of length y, and then I take another line of length z. All right, now I combine them together. If I combine them together, I have a side whose length is x plus y plus z, right? Yes, Shreya, this is going to be the last part for polynomials. Combine all the three parts. We've covered all the concept of polynomials for grade 9 in good depth, okay? Later on, what we may do is practice questions from NCERT and NCERT exemplar. Okay, cool. So now, as you can see here, this is going to be x, this is y, this is z, this is x, this is y, this is z, right? And now let's draw lines, and in a similar way we'll be calculating the area for that. Summary, yes, summary would also be provided later on, of course. So now let's connect the lines, and it simply boils down to the area problem, right? Area of square, side into side, area of rectangle, What is area of rectangle? Length into breadth, right? So this is going to be what? The area of this is going to be x square. The area of this is going to be how much? Okay, let me just put down the animation for you. Okay, xyz, 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 xyz. Cool. So now the area of the complete square is going to be the area of these individual squares and rectangles. So this is xy, this is xz, right? Area, and then it play out completely like that, yes, and then this is what the formula is going to look like. Dia, all right, I'm going to repeat this out for you again. All right, first thing, what have we done, Ria? We've taken a length of side x, x, y, z. I'm sure you've understood by now that they are variables. They can be any number, 1, 2, 3, 4, 5, 6, whatever they could be. All right, look, x, and then this is y. I'm sure you can check that out. And this is z, okay? What we've done first step is combine them. So now we have a single line whose length can be x plus y plus z, right? Because we are combining all the three lines together. And then I'm constructing a square with the similar line of length x plus y plus z, and I'm drawing lines and breaking the area. All right, so when I draw these lines, I break the area, and now all I've got to do is calculate area of this, this. So some of them are rectangles, some of them are squares, and when you calculate the area, it is going to, okay, let me just rub these off so that the terms are clear to you. And then when we join these off, we get the formula. All right, x square plus y square plus z square. And in simple form, once you combine the like terms, this is going to be x square plus y square plus z square plus 2xy plus 2xy plus 2yz plus 2zx. All right, this is going to be the formula for it. Very good. Come on now. Now comes the 6th and 7th identities, x plus y whole cube and x minus y whole cube. Now, I'd like to give you a hint for the visualization for this. This is going to be related to volume, because the side of the cuboid, the volume of the cuboid is going to be what? Length into breadth into height. And the volume of the cube is going to be what? Side cube. So if you want to visualize these cubic identities, they are going to become three-dimensional. So x plus y whole cube can be visualized as a cube of side x plus y. X minus y whole cube can be visualized as a cube of side x minus y. And by the way, these are going to be the formulas for this x plus y whole cube and x minus y whole cube. Okay, easy way to remember, not get confused. When there's a plus here, all the terms would be plus. When there's a minus here, as you can see, all these operators would be minus. Cool. Now let's go ahead and use these identities now. The 8th identity is going to be this. This is something that I will touch upon at the end. All right, so come on, let's go ahead and expand this using standard algebraic identities. Come on, let's do this one together. We have been given 3a minus 4b whole cube. So first thing that you need to decide is which algebraic identity is going to be applicable here. So look, x minus y whole cube is what we can use, right? And how can we use this? When you compare these two, in the place of x here, you have 3a, and in the place of y, you have 4b, right? When you compare x minus y whole cube with 3a minus 4b whole cube, in the place of x, you have 3a, and in the place of y, you have 4b. So all you've got to do here is, in the formula, x cube minus y cube minus 3xy multiplied with x minus y, plug these, okay? Substitute these. Come on, let's do this together. All right, Shubhi, I'm going to repeat this again. Look, we have been asked to expand 3a minus 4b whole cube, right? Now, when I look at this and I look at x minus y whole cube, I see that this is similar, right? Because in the place of x, I have 3a, and as you can see, in the place of y here, I have 4b, right? So all I've got to do here is, in this formula, x cube minus y cube minus 3xy multiplied with x minus y, I will have to substitute these values. And that is what I'm going to do, and you are going to do it along with me. All right? So come on now, x cube first. In the place of x, substitute 3a. So this is going to be 3a whole cube minus, in the place of y, substitute 4b. So this is going to be 4b whole cube minus 3 multiplied with x multiplied with y. All right, so 3 multiplied with x, in the place of x, put 3a, in the place of y, put 4b, and this is going to be multiplied with 3a minus 4b. Come on now, let's simplify this further. 3a whole cube is going to be 27a cube, because 3 cube, I'm sure you know what 3 cube is. 3 cube will be what? 3 multiplied with 3 multiplied with 3. 3 times 3 is 9. 9 times 3 is going to be 27. And in a similar way, this will be 64b cube minus 3 times 3, 9. 9 times 4, 36. So minus 36ab multiplied with 3a minus 4b. Now you can leave it as it is. You know, this would be done. No, Dia, you won't be needing a cube diagram. I just wanted to let you know that in case you want to visualize that, the visualization is going to happen through a cube. All right, that's all I wanted to talk about. Good. So you can leave it like this, or you want to further simplify this, it's up to you, but this is going to be perfectly fine. Very good. Awesome. Fine. So come on, let's move on now and check out other identities. This is going to be the 9th and the 10th identity, x cube plus y cube and x cube minus y cube. When you expand it out, this is what you are going to get. Okay, x cube plus y cube is going to be x plus y multiplied with x square minus xy plus y square. X cube minus y cube is going to be this. Now, my suggestion to you when you're dealing with cubic identities is to practice some questions and get yourself familiar with how you're going to use the formula. Trust me, you're not going to get this if no practice has been done from your side. Doesn't matter how many times you listen in a class, unless and until you practice this on your own, you're not going to get it. So my suggestion to you will be, now that I'm sure you guys have understood this, please make sure that you practice some questions by applying these identities. All right, so come on now. Let's use these identities now. So what we've been given is this, right? So let's go ahead and check this out. All right, so I'm going to bring on the formula now. Okay, now x cube plus y cube, compare this to this thing now. In the place of x here, in the place of x you have 3a, and as you can see, in the place of y you have 2b, right? Good, Nitin has given us the answer to that. So, all right, so I'm going to substitute that now. In the place of x, I'm going to substitute 3a. In the place of y, I'm going to substitute 2b in this formula. All right, so in the place of x, as you can see, 3a plus in the place of y, 2b, and then multiply this with x square. X square is going to be what? 3a whole square minus xy, which is 3a multiplied with 2b, plus y square, which is 2b whole square. All I have done so far is simply substituted in the place of x 3a and in the place of y 2b. Now simplify this further. This is going to be 3a plus 2b multiplied with 9a square minus 6ab plus 4b square. Okay, now focus. Now focus, please. Let's change the color to make it a bit interesting. Now look, they have given that this is going to be equal to that, right? Now let's compare. I'm putting that expression that I have in the green box below, and what I will have is 3a plus 2b and pa square plus qab plus rb square. Now you have to figure out p plus q plus r, which means you need the values of p plus q plus r. And now all you're going to do here is compare. Look, p here is multiplied to a square. So what is multiplied to a square? 9. So p is going to be 9, right? Q is minus 6, because q is multiplied to ab. In the answer we got minus 6 is multiplied to ab. So q is going to be minus 6. And lastly, r, as you can see, is going to be 4. Right? Great. So now you know p, q, r. And then add them up. You're going to get an answer that is equal to 7. All right, Bhakti, look. First thing that we have done is what? We have expanded it by substituting a and b in the place of x and y. After the simplification, we got this, 3a plus 2b multiplied with this. Now what we are going to do here is compare what we got with what is given. All right, what we got is this, 3a plus 2b multiplied with 9a square minus 6ab plus 4b square. Now this is going to be compared with what is given in the question. What is given in the question has been put in a green box for you at the top. Now when you compare it, you see that in the place of p you have 9, in the place of q you have minus 6, And in the place of R, you have 4. So you know P, Q, and R. Now simply add them up and you will get your answer as equal to 7. All right, so you guys are giving the correct answer. Pretty much well understood. Awesome, cool. So there you go, the answer to this, and this is a solution, by the way, in case, we're going to be forwarding these notes to you. So this is how we get the answer as 7. Awesome. So this completes this chapter of polynomials, which we have covered it in 3 parts for you, and this is going to be a homework question. But other than this question as well, please open up your textbooks and then solve a few questions so that you can proudly say that you have completed the topic of polynomials. Do the same for number system as well, because remember this, math is something you're going to get only with practice. You're not going to understand math by reading math. Reading math is not possible. Math is the art of problem solving. Okay, so you got to be solving problems. You got to be putting the paper on pen and then working things out. Okay, cool. The next topic is going to be coordinate geometry. Now, for students who have joined us late, I'd like to repeat the advantages of the BYJU'S classes 2 teacher advantage. The link to this could be found in the description box. I'm sure you guys are going to love it. Okay, because teaching the concepts and simultaneously being present to answer all of your doubts and concerns is nothing short of magic these days. Cool. Next thing, the Telegram channel, again, the link to this could be found in the descriptions box, and the session notes would be shared only on the Telegram channel. And the upcoming session is going to be, we're going to pick out some questions that we feel are really important from an exam perspective and conceptual perspective from your textbooks. And this session is going to happen Thursday. And lastly, this is the end of the session, okay? And this is the end of the chapter that we have completed in 3 parts out for you. If you like what we do, hit the like button. If you feel your friends are going to be benefited from seeing this video, or anybody you feel, share it with them. And if you still haven't subscribed, make sure you do. Otherwise, you're going to miss out on the notifications, updates, and all the amazing sessions that come by your way. I believe the next topic is going to be coordinate geometry. All right, it's going to be a fairly simple one. I hope you guys have understood whatever we tried to convey today, right? I hope those visualizations have helped you in knowing how a plus b whole square can be visualized, okay, or can be drawn, right? That's a pretty powerful thing. Until the next time we're meeting, remember to take care of yourself, okay? That's really important. Please make sure you're practicing questions, because as I always say, you're not gonna read math, you're gonna work math out. So make sure you are practicing. If you'd like to refer back to these videos that we've done for you, they are going to be pretty helpful as well. So you can rewatch it. All right. And that's it from my side. Take care of yourself. Thank you for your time. Bye-bye.